And then next, I just want to talk a little bit about our speaker tonight. So we're very pleased to have Dan Eschenasy to make the presentation about what drives building code requirement for foundation design. Dan is a forensic engineer with over 40 years of experience in structural engineering. I think most of you know in 2022, he retired from the New York City Buildings Department, where he was the chief structural engineer, and joined the GMS as a principal forensic engineer. In his position at the Buildings Department, Dan was typically the first engineering responder and investigators to almost all major New York City building incidents, such as collapse of buildings, retaining walls, cranes, or other construction installations. On September 11, he was tasked to organize the engineering response to the disaster. He also was a member of the ASCE FEMA task force that investigated the World Trade Center collapse. Published in various technical magazines, the result of his forensic investigations and related statistics became the basis for changes in the structure and the construction chapters of the New York City Building Code. For example, excavation, rock blasting, underpinning, and periodic inspection of retaining walls. So now, without further ado, let's give Dan a warm welcome. So Dan, I'll switch the screen to yours.
Hello. So thank you very much. I am very honored by the invitation of the Geo-Institute to give this lecture. And thank you all for attending this lecture. I really hope you are not going to be bored. I would prefer to give this presentation in live, but to see reactions, but that's what it is. So I was participated in the drafting of 2008, 2014, and 2022 New York City Building Code, and this included participating in the Chapter 18, which is soils and foundation. Also, Chapter 17, inspection, and also Chapter 33, safety, construction safety. And by some chance, I ended up being a corresponding member of ASCE Foundation Committee tasked to prepare a foundation regulation, foundation and geotechnical regulation for ASCE. So this experience, right now it doesn't have a number, so it's XX Foundation Committee, okay? So this experience with XX Foundation Committee was so strange, so different from what I experienced in New York, that as a matter of fact, I wanted to give this presentation, this lecture, just complaining about how the people outside New York City want to prepare a standard for foundation. But in reality, these are very good engineers, very good practitioners, and this is being recorded, so I decided to just talk about what drives building code requirements for foundation design. So from my experience, building code requirements are driven by accidents, mainly by accidents, of course, by new technologies and by new methods of calculation, but mostly by accidents. And I started to look for accidents related to collapse of structures due to soil collapses. And you don't find many, but it turns out that I found out that one of the first pyramids that were built, this one, Meidun Pyramid, collapsed because the foundation was on sand, and this was the only thing that was holding the entire weight of the pyramid. Later on, a couple of years or hundreds of years later, the Imnotech builds the Gizeh pyramid on limestone, and it stood. And people were so impressed that they declared Imhotep as God. Okay, so this was probably the most revered geotechnical engineer or whatever architect who understood foundations. But there was knowledge about foundation from antiquity. This is, you can see here the layers required just to build a road in the Roman Republic and Roman Empire, and they were good engineers. And if you compare all these various strata with what DOT requires for street foundation, you will see that maybe the Romans were doing better. And at that time, they did not have trucks, they did not have fire trucks, there were just chariots and people walking. The Roman also produced, this is some text from Vitruvius, who talks on the foundation and wall and the establishment of towns. So pretty much there was already 2,000 to 2,500 years ago a good understanding of what needs to be done to keep a building standing. Of course, you cannot talk about foundation and accident without the Pisa Tower. I just am going to mention that this was leaning. It did not collapse because there was some kind of interruption in the construction, and after it started to lean, after 200 years, they continued to build and they tried to rebalance the tower. And I have to mention that in 1950, 1960, some geotechnical engineer tried to fix it, and as a matter of fact, it went worse. So in English language, the first known text about foundations that was it was already printed. It's 1710 by Moxon. This is about at the same time as Newton was publishing his his findings, and he was talking about foundation, how to build proper foundation, how to inspect the soil for foundation. In the United States, the first text known about foundation was the United States produced at the United States Military Academy, and it's very funny that the Military Academy produced an elementary course of civil engineering. Okay, so it was, they had one for military engineering, but this was for civil engineering. And as a matter of fact, at that time, this was a national, it was a national institution. In New York City, the first regulation I could find talking about footing and foundation was about 1860, and it was part of fire regulation. Skipping. So what I'm going to do in this presentation at the beginning, I will go through various building codes and the way the main chapters were listed and presented shows also what was driving the foundation construction in New York City. And the major code in 1898, which covers the entire city, which became a city in 1899, had a chapter on excavation and was discussing about license and inspect. So it started with excavation, okay? And it gave some indication of buried capacity of the soil, tests and borings. It talked about pressure on the footing and foundation depending on the building occupancy. And it even gave formula for piles, okay? And talk about foundation walls. At that time, most of the buildings in New York City were built with bearing walls, so pretty much foundation wall was an essential method of supporting buildings. This is from a handbook published in 1910, major US cities. And what is interesting is that there is almost complete agreement on soil capacity in the different cities. I don't know if you can read: Philadelphia, Atlanta, Portland, New York City, Chicago, and so on and so forth. So if you would see this table for thickness of wall, it would be very different. There was no agreement of thickness of wall depending on the height of the building. So pretty much by 1910, at the beginning of 1900, there was a clear empirical understanding of the capacity of the soil. And moving back to 1916, which was another major new edition of the building code, you can see it's again started with excavation, included safeguard on license, support of party wall foundation. Again, it's interesting, they were already calling presumptive soil bearing capacity. They recommended that in proportioning the area of footings only, dead load shall be considered, but in no case to exceed the safe load. Discuss about foundation piers and caisson, pile foundations. They gave hammer formulas, again foundation walls, and now they introduce retaining walls. It's interesting that retaining wall was introduced in 1916, and it's clearly explainable by the fact that the city was expanding in the northern part of Manhattan, in the Bronx, even in Staten Island, where there were significant difference of level between the various streets, and you had to build retaining wall between properties. So you see here an accident in 2005, 6, 7, something like this, and this is one of the retaining walls. So pretty much the interest of retaining wall, what brought the retaining wall in the building code, is the interest of construction and development of the city. Now, before I move to 1938, I have to, when I talk about accidents, the main accidents that I could find in publications, in New York Times, historical New York Times, are soil falling. Not really, I couldn't find anything about fatalities due to soil settling and stuff like this. So there were no significant fatalities. Now, accidents of retaining walls happened. I was myself very much involved in examining the collapse of the retaining wall of Perry Hudson, and this accident led to change in regulation, and the Buildings Department introduced the periodic inspection of retaining wall. Now, moving to 1938, this was a very good, solid code. It started with investigation. It gave presumptive bearing values. It had a detailed classification of soil based on spoon blows. It talked about eccentricity on footings, which I found that not many people, not many civil engineers know how to deal nowadays, and I will mention what was the case. It introduced increase in capacity due to wind loads, had extensive discussion on piles, and strangely, it still maintains steel grillage footings, although at that time there were no more used in practice. Moving to 1968, foundations, this is pretty much what you had before: soil investigation, foundation loads, footing, foundation pier, foundation wall, pile foundations. It described how the pile should be built. Underpinning got a separate chapter, and introduced stability, which means that there might have been some problems already with stability of retaining walls, but they time. Okay, so this is the major new thing. Underpinning existed in the previous codes, but not as a separate chapter. So moving to the present code, okay, what is new, or what is new since the 1968? Dam proofing and waterproofing is new. We have shallow foundation. We have now terminology. Deep foundation was introduced under this term in 2014. Driven deep foundation 2014. This code 2022 introduced permanent pre-stress rock and soil anchors. Liquefaction analysis that was in the code one way or another since 1995. Underpinning has a large new dedicated area, and we have geotechnical peer review. So what we see is that, for instance, the use of rock anchors increased in the city, and there was clearly a need to codify their use. I will explain why geotechnical peer review became important and was introduced, but pretty much the changes in the code show just the needs of the industry of geotechnical engineer to have clear instruction and clear regulations. If you go by the empirical provisions that already existed in 1900, any civil engineer would produce drawings and calculation for spread foundation. What was different, what was really the area of geotechnical engineering was piles. Okay, piles were you could use piles because the codes, the 1916 and 1938 codes told you what was the capacity of the pile if you did some tests on the pile. So you had timber pile, concrete, wall structure, steel, concrete field. 68, you had new compacted concrete piles, composite piles. Okay, so you see, these are just new methods of supporting foundation by deep foundation, by supporting buildings by deep foundation. So I have to mention that I had a very bad experience with helical piles, and when I was at DDC, I really promoted a study on small diameter piles, and pretty much it became the basis of the pile regulation or small pile regulation that was introduced in 2008 building code. So pretty much these are the pile that exists in the building code now. It shows new, so there were new technical developments, new methods besides timber pile and the concrete field, steel piles. There were new steel piles, and we have helical piles. This is a major introduction. I was very skeptical at some point about helical piles because the manufacturer would not produce the testing data, were just giving tables, but they work, and they are very popular now throughout the country. So this foundation, ASCE foundation standard, has pretty much the same type of piles, maybe under different organizations. They have timber piles, driven piles, batter piles, and so on and so forth, micro piles and helical piles. So pretty much on piles, the only thing that drives building code is the new development in creating new type of piles and how to produce them, how to use them. So I had my own contribution to piles. These are horizontal piles that I had used successful in a very dramatic situation. This was 911 responding center where they were getting all the medical emergencies, and they were supposed to send them to the hospital and send EMTs, and it was settling half an inch per day, the soil. So using all kinds of solutions, including these horizontal piles, it worked for a couple of days till the call center could be moved. Anyway, I have to mention that it's not just changes in the type of piles and the manufacture of piles and the calculation of piles, but right now the new building code has this new text, the approved geotechnical reports and construction documents prepared by the registered design professional will be used to determine compliance. So what this means is that the geotechnical report now is definitely part of the construction documents. As a matter of fact, in another part of the code, it requires the geotechnical report to be submitted. It's not just the pile results of borings, but an actual geotechnical report. I have to mention, if you want to know what's new, in relation to code in New York City, you have to look at the fire code. This area on the diagram of maximum allowable vibration change here with limit B. This is a major change that doesn't exist in the national standards, and if you go in the fire code, you will see that there are new methods of monitoring the effect of vibration, not by reading the vibration, but actually reading the tensile developed in various type of materials. Okay, so this was design of piles. We were talking about design of piles, design of new foundation. But you see here, this is new building application by Borough since 2000 till 2022, and you see there was a significant increase in buildings, in new buildings, and it leveled around 2009. And we have here excavation violations. They pretty much match the number of new buildings, but then they continue to increase, and they were very high, although the activity of new buildings diminished. Obviously, you know by now that all this was the result of bad underpinning and excavation doing damage to the adjoining property. What's interesting is that since 1880s, the building code in New York City had some kind of text discussing excavation affecting adjoining property. So what was major and started the foundation part of the code was not bearing capacity of the soil, was how do you excavate in the condition of a city where you already have other properties, already buildings installed, properties that you might damage with your excavation. And you had a temporary support of adjoining property. It discussed already in 1880, discussed license to enter adjoining premises. And it says any person that's causing an excavation to be made shall be afforded the license, okay? And if it's not afforded, the owner shall have the responsibility of providing temporary and permanent support. Even more, it said that excavation 10 feet of less in depth, is providing the support was the responsibility of the adjoining property. So this has existed for a long time, and the text talked about also about underpinning. So underpinning existed in the city for a long time. You see here underpinning in around 1902 for the building of the subway. Major building were underpinned. All the underpinning and all the examples show significant shoring of the buildings, and there were manuals, everything said shore. It's very strange. What happened is this technology, these systems that pretty much they had only 2 major cases of collapses building the subway was forgotten. And suddenly in New York City, pin underpinning became the system, okay? And pin underpinning was adopted by geotechnical engineers, structural engineer, and everybody else. This is from Structure Magazine. You probably recognize this cartoon. The idea is that you shim and jack, you do this pin in a certain order, and everything will be fine. I had a very clear bad experience with this type of underpinning. As a matter of fact, I did prior to this type of underpinning calculation. I said it won't work. It was pushed despite my resistance, and obviously the building moved. Although the underpinning company was the top underpinning company in the city. So, but what's interesting is everybody bought into this. ASCE, as you see here, graphic courtesy of Structural Engineering Association of New York. This cartoon existed on all the drawings where there was possible. The structural engineers, the top structural engineers in the city had this cartoon on the foundation drawings. And They never looked at the building to be underpinned. They never looked at this. They said it's fine. It turns out that building department made significant efforts to fight underpinning accidents. And I have to mention Delia Shumway, Tim Lynch, Bobby D'Alessio, Matt Milner, Jeff Isley, and many others. But most of them bought into this underpin method, which of course, if you do everything, if you do the box proper, if you shim, everything will be okay. But it was not enough. Accidents continue to occur. So pretty much there was already in my. I thought that people will read the text of the 2008 Building Code, which says shall be installed in such manner so to prevent the lateral or vertical displacement of the adjacent structure. There was no calculation. This underpinning came without any calculation. In 2014, there was more text. The design shall take in account the effects on foundation and structure produced by the lateral X pressure exerted on the foundation. Accidents happened after 2014 as well, very clearly, and there were some text in the code in chapter 17, which is special inspection, where requires a special inspector to do the drawing or to agree to the drawing for the underpinning and the inspection of structural stability. Now, finally, the 2022 Building Code introduced an engineering of underpinning, which means there should be an engineer that should look at the adjoining buildings, that should evaluate the adjoining building, prepare a report, assessment of the building or subsurface conditions. So pretty much you cannot do an underpinning just by a cartoon or by a properly shimmed pin underpinning. You need to use engineering knowledge, judgment, and calculation. And as a matter of fact, there are changes, addition in the chapter 17 for design documents that are specific in what to monitor during an underpinning. So one of the reasons this underpinning was bought by everybody was that nobody was responsible. It was some kind of delegated design. Pretty much you have it on the drawing, but it's not exactly you, it is the contractor. So pretty much the responsibility was pushed on the contractor. The engineer was saying, I'm not into means and methods of construction, I don't have an insurance for this, and so on and so forth. So it turns out that this ASCE standard on foundation, that's all they talk about, delegated design, deferred submittal. This is what they want to at least in the main chapter, in chapter 1, that's what they want to regulate, delegated design. As a matter of fact, delegated design is not an engineering, belongs to an engineering standard, it belongs to a engineering code of conduct, okay? Anyway, what is delegated design? It's a process where the design professional of records defers detailed design engineering responsibility for certain building elements. Building permit is provided by the authority having jurisdiction contingent upon the delegated entities providing PE-sealed documents, shop drawings, whatever. So pretty much delegated design is not just in geotechnical, it's not just underpinning. Most pile design, most deep foundation design are delegated design. This is not just a problem. This is not just a problem of geotechnical engineering. AIA and AIC, have also a text on delegated design. They say contractor assume responsibility. Separate the professional engineer or contractor have separate written contracts with the owner, and the delegated design should be conducted based on a performance specification prepared by the design professional. This is very much important now, since you have a lot of design builds where delegated design is extremely common. So in New York City, in New York State, it's not so easy. Not everything is allowed to be considered delegated design. So pretty much New York State Education Department has a list of how a delegated design should perform. The work is ancillary to the main project. The consultants specify all the parameters. The contractor's design professional design to those parameters. The contractor's design professional is licensed in New York State, and the consultant reviews. So it's not so simple. And the case, which is the Council of American Society of Structural Engineers, American Structural Engineer, has and prepares documents, says, okay, is there a standard of care? When you do a delegated design, you have to make sure that there is a standard of care of the profession. If there is not, can it be modified or clarified by a specification? Is a structural engineer of record responsible for the qualification of the structural specialty engineer? Structural specialty engineer is the engineer that produces a delegated design. Will it be reviewed? Will it be coordinated? Who is responsible? The spec should say who is responsible for the final design. What's interesting is that there is no standard of care, or I don't know of a standard of care for geotechnical professions. There are now licensed professional engineers in New York State, but there is not a standard of care. These people in the ASCE standard, they try to create a standard of care in the standard, which should be an engineering standard, how you do calculation, investigation, and so on and so forth. And this is a text. This is a text for delegated design, and there were infinite discussion about this issue. Although, in my opinion, said forget about it, put it in the commentary or create a standard of care. But I'm not a major player in that group. So, talking about delegated design, so you have exploration, which include, you have to say how many borings, you have to describe the geological formation, groundwater condition, topography, describe the soil. But what's interesting is, because of this delegated design, for instance, for piles, there is not much interest in doing a full, complete exploration of the condition on a site. This is, I'm talking in general, not in New York City, where you have lots of borings requirement. So pretty much they push the risk on the contractor who will install the piles. The contractor might not find the rock they were counting on. They might find all kinds of stuff at the surface. So pretty much the risk is pushed towards the contractor and whoever is in charge of the delegated design. Now, as a matter of fact, I wanted to introduce this peer review of geotechnical design in New York City, just because there is something called structural peer review in section 18.2, which all the buildings over 600 feet, all the buildings with a ratio larger than 7 and so on and so forth, need a structural peer review. And while I was looking at the peer review, the drawings were very good, nice, whatever you want, but they were just showing, some kind of caisson without any reinforcement, without any indication. So pretty much this was the practice, to send everything to a delegated design. So what was the purpose of a structural peer review if you don't know what the foundation is good for? So in addition of these structural peer review buildings that should have their foundation peer reviewed, risk categories 3 and 4 where seismic site is class F, and of course where performance-based design is utilized. So pretty much you have to do all this stuff, and this is the task of the peer reviewer. You have to confirm the investigation meets the code, all kinds meets the code. You have to do an independent check of foundation capacity. You perform independent settlement calculation. You confirm design assumptions. So in my view, all these tall buildings, everything is done by computers, and everything is highly regulated. The only place in this design where there were opinions and the engineer could make judgment not tied by any code was in geotechnical engineering. Maybe I exaggerate, maybe you don't agree with me, but at least this was my view. So, okay, so we know by now the typical code provisions. They talk about loads, capacity of the foundation system, capacity of the underlying soil, methods of excavation, spread foundation, deep foundation. What's very interesting is that there is and has been no national code, okay? No national code, and there are some reasons which I'll try to touch while there is no national code. And this led to the extraordinary success of DM702 and DM701. I think they sold 500,000 books, or I don't know how many, but extraordinary. And someone told me this is a Bible of geotechnical engineering, and it's been used. So it was not intended, but it's been used throughout the country. There used to be UBC. The requirements for foundation and national codes like UBC, SSBC, IBC were pretty lame, and they increase in time. This is IBC 2021. By now, these chapters match the chapter in New York City Building Code, or the reverse New York City Building Code chapter match this one. And it's interesting that they say foundations shall be so designed that the allowable bearing capacity of the soil is not exceeded and the differential settlement is minimized. But in my view and experience, there were limited calculation on differential settlement. Now, why it was difficult? It is difficult to have a national code is because diverse geological condition, and here are the different conditions for drill shafts. You see that in the northeast you go to hard rock. In Florida you have soft lime with some cavities. You have to be careful. In Texas you can use small diameter shafts and so on and so forth. So the local geological condition obviously dictated the practice and dictated the local codes. Now, going to Eurocode, you can see that pretty much it has the same organization than IBC and the building code, and probably they have problems with dewatering, and they have issues with ground improvement. We don't have in New York City, we don't have too much text on ground improvement, and there are not so many projects that use ground improvement. They talk about anchorage in Europe, and only now in 2022 we have not in IBC but in New York City we have anchorage, rock anchorage introduced, and they have issues with hydraulic failure in Europe, I would assume. So what we see here, and obviously I did not discuss. There are a total new area that appeared, at least in the United States, in the 70s, in the 80s, which was earthquake, liquefaction, and it was introduced in New York City Code, and there were collapses due to liquefaction during earthquake, but pretty much all the building codes still rest on the empirical or the building codes I discussed before the Eurocode. I discussed rest on empirical findings. Most of the stuff is empirical findings. There are improvements in technology of investigation. There are improvement in type of piles, but pretty much everything is still coming from the empirical findings. So now this is interesting, the exception that they don't want to discuss in the ASCE standard. And okay, laws applied, of course not, but they do not really want to talk about effect on the other structure unless your foundation, not the constructions, your foundation affects other structure. They don't want to take a freestanding retaining wall, which is very strange. Okay, and they don't want to talk structural elements about the foundation elevation. I don't know what the foundation elevation is, but so will be a somewhat limited code. Now, the engineering profession advanced significantly in terms of methods of calculation, methods of assessing risk, and most of the engineering calculation are limit states based on limit state design. The geotechnical engineering is not there yet, or not all the geotechnical engineering. So ASCE since 1980 sometime, they have introduced limited state design, and pretty much you have a ultimate limit state, which is a building capacity, and you have a serviceability limit state, which is settlement of foundation. So to define a limit state, it's a condition in which a combination of one or more loads is just equal to the available resistance. So the structure is a incipient failure. Okay, so pretty much this is what we call ultimate calculation, ultimate capacity. So ASCE has something called an LRFD that was improved in 2010, and it has limit states for geotechnical, for structures limit states and geotechnical limit states. So, and it says that the structural engineer is responsible for development of foundation factor laws at various limit states, and in the evaluation of various geotechnical resistance. While the foundation factor laws and tolerable displacement are finalized by the structural engineer, the geotechnical engineer often computes the foundation displacement. So I, as a structural engineer, I have a big problem of this requirement to define tolerable displacement. It's not so easy. For bridges, pretty much they can tolerate some displacement, but some buildings cannot tolerate displacement, and there is no standard for I could base my you know, indicating to the geotechnical engineer what is a tolerable displacement. Now, as I said, there were no big collapses of buildings due to foundation failure, or not numerous or not very known. And as a matter of fact, there were some texts saying shallow foundation shall be designed that the allowable bearing capacity of the soil is not exceeded, and that the differential settlement are within allowable limits of the structure. But I haven't seen too many calculations discussing allowable differential settlement. But the fact is that I have this list of towers built throughout the centuries that lean, which is clearly that the problem of geotechnical engineering is mostly differential settlement. And limit design has the clear requirement to calculate differential settlement. It's separate from, so the ASCE limit states, service limit states, which is sliding, overturning, bearing resistance. They have fatigue and fracture. ASCE has limit states not just for geotechnical, for everything, okay? For buildings, for bridges. Strength limit, extreme event. So extreme event would be an earthquake. And you have to verify a single pile group. You look for uplift on one pile group, and so on, so on. Punching and lateral resistance. So it's interesting. I thought that ASCE is a national code. Not really. ASCE is a national code. Maybe many of you deal with ASCE. ASCE is a national code for US, for when you work for the government, for roads and bridges that belong to the US government. Otherwise, ASCE is a model code for the various state DOTs. And the various state DOTs have the opportunity to, since 2010, I think, they have to develop their own LRFD codes, okay? And they can do it based on using all kinds of methods. But to get to LRFD, ASCE had to go through a calibration procedure, which is you select the representative structure, you calculate the reliability for selected bridges, you select a target reliability index, and based on this, you calculate load factors and resistance factors. So my main problem with the ASCE's committee is they said we are going to use LRFD methods, but they don't have any calculation, any calibration. The loads, type of loads used for bridges are not the loads used for buildings. So to just state this and make some statements without a calibration procedure is not totally proper. Maybe it will be okay because there is significant resistance in existing design. So pretty much for bridges, they decided, they found out doing all kinds of statistical calculations that the reliability in the current design is, the reliability target index is 3.5. They found that, for instance, ASD safety factors for footing bearing capacity is between 2.5 and 3, which correspond to a resistance factor in LRFD of 0.55 and 0.45. And the sliding has a safety factor of 1.5. So what do they do with this, and what is the footing capacity? So pretty much what they did is they took, you can see here, they took the service limit state modified by US Department of Navy. So they took the NACTAC values and they doubled them, okay? And then you multiply by 0.55, 0.45, and you get to the same values. So for rock, as a matter of fact, you still have a semi-empirical procedure, you have an analytical method, and or by load test, okay? Soil becomes a little more complicated, and you need to do some kind of theoretical estimation. These are the resistance factors you have for sliding, for berry resistance, and pretty much 0.5, 0.45, and sliding, because it was just 1.5, the resistance factor is 0.9, 0.85. Again, ASCE has 5 strength limits, and some include wind, some include some level of wind, is for long span. You cannot take the ASCE geotechnical prescription and just say, I'm going to design buildings based on the same system. So serviceability limit state is the main problem, and this is what has to be, at least for shallow foundation, this is the essence, okay? And serviceability limit state is based on settlement that could be immediate, should include immediate soil consolidation and creep. But the value of the serviceability limit is computed by service loads, which is pretty much dead and live load, and pretty much you are back to ASD, because you multiply by 0.45, something that was multiplied by 2, and you get to the same as ASD. Now, there is this requirement for engineers to produce angular distortions. I found this in a book, okay, and it's pretty much, you can find it online in a couple of places. But what is the authority of this graph? Okay, so it says 1 for 200, limit where tilting of high rigid buildings might become visible. Okay, 1/600, limit of danger for frames with diagonals. Okay, I kind of agree, but this is not a code. You need some clear code or studies that say this is it. As a matter of fact, I took this differential movement from Gaylord and Gaylord, okay? And it tells you, probably it makes sense. Continuous brick wall of significant height, 0.0005, whatever, it gives you some numbers. Gypsum plaster cracking, it gives you different numbers. Gaylord and Gaylord is pretty much good, okay? It represents some kind of consensus, but still, it's not a standard. Going back now to Eurocode, you can have geotechnical design by calculation, design by prescriptive measures, which is pretty much what we had in the old codes. You can design by load and test on experimental models and observational methods. This is extraordinary. So design reviewed during construction. This is pretty much what the underpinning used to be. You show an underpinning, and then during construction you say, oh, maybe it's not good, or oh, it's good, I'm going to monitor. So we have a GMS, a couple of students, graduate students from top European engineering schools. They could not explain to me what the observational method is. And again, Eurocode has direct methods where you separate ultimate and service low limit states. You can have an indirect where service limit states are used for everything, which is again ASD, and you have prescriptive conservative base. But you have to understand the Eurocode covers 10, 15, I don't know how many different countries where different practice, okay? So the limits are overall stability, bearing resistance, sliding resistance, adequate structure capacity, no combined failure of ground structure. This is very clear. No excessive settlement, both immediate and delay. But what is interesting is they have design against heave, both immediate and delayed. Design for vibrating loads. It's interesting that they consider heave and they consider underground, the underground water pressure was a significant problem. And it is one of the conditions they put on the buildings. In New York City, I've seen only one building where the flat slab design considers the effect of the underground water in case of a flood. I'm going to skip. I'm pretty much at the end of my presentation. And in conclusion, there are lots of inconsistency in the building code. What drives the building code is not necessarily accidents, is the existing practice that is based on the local practice that are not easily relinquished. Okay, so pretty much we are still in geotechnical area. We are still heavy into empirical design. Thank you very much.
Hey, thanks so much, Dan. That's a very informative presentation. You know, I hope a lot of good stuff there. I hope everybody took some notes. Now we have a quiz. So the first question is really a bonus question. Which discipline are you practicing? So I see I already got 80% answers in. interesting, seems we have like a 50% of geotech engineer and about 20% and 20% of structure and 20% of civil, and the rest is others. Interesting audience group. Oh. So the first question is, does the 2022 fire code increase the vibration limit for wood frame buildings or masonry buildings or building over 4 stories? Seems we got almost 80% of the vote in. I think the popular vote is the correct answer. Yes, it's building over 4 stories. Next question is geotech peer review required for all new buildings above 7 stories, or new buildings taller than 600 feet, or new building with 20,000 square feet area? So almost get 80% in. I think there's some like a split in there. About 40% choose the first one. About 50% or 45 to 50% choose the second one, which is the correct answer, and about 20% choose the third one. So the third question is specific instructions for differential settlement limits can be found in ASCE 7 or IBC or ASCE or RFD. All right, we have about 80% voted. Yes, the correct answer is a popular vote. Is the ASCE or RFD. The first question is, inspection of a joint building to be underpinned was a requirement of the 1916 New York City Building Code, or 1899 NYC BC, or is 2022 NYC BC, or is all of the above? Look at our voting, and the correct answer, yes, it's all of the above. Final question is ASCE serviceability appendix useful to set foundation serviceability limits? It's a yes or no question. And we have like 70% choose yes, but I believe the correct answer should be no, right? Dan, do you want to?
Yes, I apologize. This is one of the problems. This is one of the problem with the new ASCE foundation standards, that they refer to ASCE 7 for everything, including serviceability. The serviceability limits in ASCE 7 are just for comfort of the people in the buildings. They are not for other issue like machine elevators, and so on and so forth. So pretty much it's just a comfort limit. So they are not sufficient. I apologize. Many of these questions, the answer of these questions were not fully discussed in my presentation, but that's what it is. Okay, I'm sorry.
No, I think that's fine. I feel like the questions are very inspiring, or the speeches did include a lot of information. So we have. Let me go through the question box. I don't see any question there, but one of the audience made a comment saying, for the record, the observational method employs instrumentation to predict actual site conditions. It's need to modification of the original design to suit actual ground conditions. I think that's a good comment, but there's no question. So we're for 5 minutes past 7. So if there are no further questions, thank you very much again, Dan. A very informative presentation. So some of the audience already raised a question. Can you share the slides, or I'm probably gonna reach out to you separately. Say if you want to share the slides or not.
Yeah, the slides can be shared. Yeah.
Okay. All right. Perfect. So again, thank you again for the presentation tonight. So we'll see you in our next event. Everybody have a good evening. Thank you.
Thank you.